Alright, so in this video, we're still working on chain rule. We're going to do a bunch more examples, but I want to do a method of less notation involved. So this is called the outside-inside rule, and it works like this. In words, differentiate the outside function f and evaluate it at the inside function. So you can see it in the notation here. It says f prime. So whatever the outside function is, you take that derivative. The inside stays the same, no derivative. Then after you're done with the outside, inside stays the same, then you multiply times the derivative of what was inside. All right, so let me show you an example. So in this function here, I need you to break it up and consider who's inside and who's outside. So we have e to the power of cosine of x. So in this case, cosine of x is actually in the power. So he's our inside function, and e is our outside. So think of this as e to something, a function of x. So when we go to take our derivative, we're going to use the rule for the outside function. So e to a power of x, that is going to be our outside rule. What's the derivative of e to the x? It's just itself. So in this case, the derivative of the outside is just e to itself. So cosine of x, the inside stays the same. So the derivative of e is itself. The inside stays the same. Now we multiply that times the derivative of the inside. So I'm going to write the notation, so d dx of the inside. This says take the derivative of the inside. Some students find this helpful to write it before you do it, but if you just want to write it straight up, the derivative, that's fine too. All right, so e to the cosine of x stays the same. We already did that part. The derivative of cosine. You remember what the derivative of cosine was? Negative sine of x. Now you can leave it like this, just make sure you have the parentheses so we understand this is multiplication, not a subtraction. But I like to write the sign in front and then the e. That's just my preference. Order technically doesn't matter. If you want to simplify it, which my lab probably would want you simplifying, the negative should at the very least go in front. That's it, that's the derivative. So notation, none. It's just the concept of inside, outside. Take the derivative of the outside, keep the inside the same, then multiply by the derivative of the inside. Let me show you another one. So again, we need to talk about who's inside and who's outside. So take a minute, pause the video, write down what you think is inside and outside, just like I did earlier. All right, so if you got it, the inside is all this parenthesis. He is my inside. The outside is cosine. So the derivative, dy dx, or y prime, either way. Chain rule says we take the derivative of the outside. What's the derivative of cosine? We just did that, didn't we? That's negative sine. But the inside has to stay the same. So you just copy the inside down. Do not change it here. The next step, you've already done the derivative of the outside, inside stay the same, times the derivative of the inside. So d dx, the derivative of what we called the inside. If you want to just write the derivative, that's fine. You don't have to show a ton of work here. In the future, you'll actually want to show less work. It'll save you time. So negative sine, inside stays the same. We already did that. All we have to do is take the derivative of the inside. So the derivative of x squared is 2x plus the derivative of e to the x. That's just e to the x. So there you go. This would be your derivative. If you want to put the 2x plus e to the x in front, so negative, then the 2x plus e to the x, then the sign, that's fine. Order doesn't matter because these are multiplying. So it's up to you. Do you prefer the formal definition of writing down u, writing down y equals a function of u and taking the derivative, or do you prefer this way? Most students I find prefer this method. All right, so again, in part E here, I want you to pause the video. I want you to try it. Write down who's inside, write down who's outside. Take the derivative of the outside, inside stays the same, then the derivative of the inside. All right, hopefully you tried it. So I'm going to write this down. The inside is the parentheses here. Ooh, well that's kind of weird looking. The outside is tangent. So where do we start? The derivative of the outside. So what's the derivative of tangent? Isn't that secant squared? The inside stays the same. Times, we're going to take the derivative now of who? The inside. Wait a second, something here looks a little funny. All right, inside has two terms, so we're going to take the derivative of each term separately. This 5 is going to 0 because he's a constant. How do we take the derivative of this? I have sine of 2t. Ah, this is two functions inside of each other again. So for this part here, we need the chain rule again. So how does the chain rule work? We mark who is inside and we mark who is outside. So this is actually a chain rule inside of a chain rule. It's a double chain rule. So you got to be careful with your notation here, or at least marking your steps and keeping track of your steps. All right, I'm gonna carry stuff down. We already did this part in front. Times. All right, so we're ready to do the derivative. 5, that's gone. It went to 0. Negative, we do the chain rule. So the derivative here would be the derivative of the outside. Derivative of sine is cosine. Inside stays the same. Okay, chain rule is going on here. We did the derivative of sine, inside stays the same, times, what's the derivative of the inside? You can write it, or you can write what you need to do. It's kind of up to you. All right, so what's the derivative of the inside? 2t. That's all you got to write, and then you're done. So copy everything else down, because all you have to do is that last step. Times, I'll clean up the negative sign in the last step, all right. All right, so what's the derivative of 2t? 2. All right, one more line just because it's messy looking. So we have a negative, we have a 2. I'll put the cosine in front because he doesn't have a square and he's less messy. And then put my secant. So I'm just rearranging in what I consider to be the simplest form to write this in. And that's it. There you go. So even if you have a chain rule inside of chain rule, the inside-outside works. If you use the formal definition, you would have had to create, instead of using a u, you would have had to use v equals 2t, and y equals sine of v. And you'd have to do dv, dt, and dy, dv. It's just a whole bunch more work personally, but absolutely can do that. And that's it. That's all my examples for you. We have one more chain rule topic. It's actually a special case, and you'll have chain rule. So practice. This requires a lot of practice. Do your homework, study hard, and I'll see you in the next video.